It's fine. Any question, guys? Any questions from whatever we have covered so far?
So
I have one question I'll answer. Anything else?
one question.
Yeah, go ahead.
Going back to the first assumption of the linear regression, you said that any of the x variables which are not linearly related with y should be dropped. So my
Yes.
question is that if we know from our previous experience or our domain knowledge that the variable which is not linearly related directly impacts my dependent y, and I
Mhm.
cannot drop it from analysis, then what should
Right.
we do?
Two ways, right? First is you transform that variable. We also talked about transformation, right?
Yes, I mean,
So you transform the variable. If after transformation it becomes linear, you use it, right? But even after transformation, if it does not become linear, then nobody has actually told you to use linear regression, right? Linear regression is just one of the techniques which can be used to do regression problems. There are other techniques also which we will learn. So if you think that a certain variable is not linear and it cannot be converted into something that is linear, and you need to use that variable, then the only thing is you cannot use linear regression. You can
okay,
use any other technique.
okay,
These are assumptions of linear regression.
okay, got it.
Yeah. All of you understand, right? So all the assumptions that we have looked at are assumptions specific to linear regression, not regression problems in general, right? These are only problems of linear regression. If you change the technique, these assumptions are not required to be valid, right? Only if you're using linear regression, this assumption is important. Okay. Anything else?
Sir, I have a question in linear regression using Python.
Yeah.
The previous file. In that, you have taken the example of TV advertising. I think we have done the advertisement.
Yeah. Okay. You need to go. You want me to go to the Excel file?
No, no, not the Python file. I think you have shared.
Oh,
Let
is
me.
it the Python file? Yeah.
Yes, yes. It's a
Yeah.
linear regression dot IPN.
Yeah. Tell me.
So in that, I have a query,
Mm-hmm.
which is, you have taken sales and newspaper to remove outlier and handling. Why not the TV and the radio?
Okay. Just a
Outlier
second. Let me go to that place where we
above, above. I think above.
have above. Okay.
Here.
Yeah. Okay.
It
Got it. Yeah. I will show you why. So I've taken sales and newspaper, right?
right.
Yeah. So for example, let me read the data.
Yeah, sure.
Um,
So you have removed here the first column.
okay. Yeah. Now, the reason I have only used these two variables is these are only for demonstrating how to do the outlier treatment, right? This does not mean that you should only do the outlier treatment for sales. What we are doing is we are just showing is if you want to handle the outliers, this is how you should do it. But ideally you should do this for all the variables. So if you remember in the last class I showed you one function, right, which can basically do the outlier treatment for all. So you should ideally use that function. If there is an outlier, it gets removed. If there is no outliers, then it does not make any difference.
Understand. Then the next question is, sir,
Yeah.
when we are removing outlier, that is quantile 0.99 and 0.01, right? In
Mhm.
above, I think 9 cell, go to the 9 cell. And then why we are calculating between that? I mean, the P1, P2, P3, P4. I mean, ultimately we need either P1 or last one, 0.99 or 0.1. So why we are
Mhm.
calculating quantile for the other one, right? And you
Oh,
can,
right. So for example, often what you might see is 1% and 99 percentile are the usual outliers, usual suspected outliers, right? But
Mhm.
what we also need to know is if certain values are very common. So that's why what we do is, so we look at few common percentiles, right? So that we know. So for example, if I look at P25, I know that 25% of my observations are less than equal to 74.3, right?
Mhm.
Similarly, if I look at P50, I know that the median is 149.75. So
Okay.
these things basically help you to understand the variable better. They do not have any direct role to play in the outlier treatment. The outlier treatment is done based on only P1 and P99, but the other percentiles basically help you to understand the variable better. So for example, if you work in a particular problem which you do not have domain knowledge on, right? So
Okay.
in that particular case, what this will do is, this will basically help you to get domain knowledge and also verify if the data that you have got is in sync with what the business expects, right? So after this analysis, what you are supposed to do is get back to the business with your observations. So one of the observations will be, in my data, 90% of the people, 90% of the observations lie less than equal to 261.44 for TV spent, right? You
Right.
give this line to the business. If they agree that this is what they see in the actual business as well, then and then only will this data be used for analysis. Because you see, your model will be based on a sample, right?
Right.
And that sample should be very similar to what the actual population looks like.
Mhm.
These percentiles help you to verify that.
Okay. Okay. Fine. Fair enough. Sir, bottom of that, there is a one, I mean, you have draw pair plot
Yeah,
and the joint plot. First,
yeah.
I wanted to know, I mean, what is the relation between, you have draw the relation between
No, no.
sales and,
I'll come to this. I'll come to this.
okay,
I will
okay,
talk about
okay,
this later. Yeah,
okay, okay. Pair and joint plot, you will later on, we will discuss the
yeah, yeah.
joint plot.
Later. I'll talk about these plots later.
Okay, okay, okay. Fine. Thanks.
Yes. Anything on regression?
Regression, regarding regression, sir, bottom of that, you have calculate correlation. Can I ask the question? I mean,
No,
between,
I have not gone till correlation, right? I will,
okay,
when I go there, I will cover it.
okay. Actually, we have studied, that's why I was.
Yeah, I understand. I understand. Okay. Anything else?
Sir, if we have a categorical variable in the data, right? So,
Hmm.
what are the during the data cleaning and data preparation? What are the various things we have to consider during the categorical variable, treating the categorical variable?
I did not cover categorical variable, or did I?
Okay,
Did I
okay,
cover categorical variable last week?
okay. Then you do. Then I'll put my questions.
I did, right? Okay. Yeah. So for categorical variable, what you need to do is basically convert them to dummies.
Only this thing we do.
Yeah. Right.
And if I have a missing in the categorical variable, then we have to
You replace by mode.
replace by mode.
Yeah.
Okay. Any other thing? Any other thing that I have to
No.
consider?
No. No.
Only two things. Okay.
Yes. There is no outlier treatment for categorical variables.
Okay.
Okay. Now, I'll answer your question with break. Uh, Now, let's get back to where we were. We have stopped here, right? After creating dummies. Yeah? Okay. Okay. So what we did was we created dummies, and then we basically have a data set which is now ready for building the regression models, right? That's where we stopped, right? Okay. Cool. Any questions on the steps that we have followed? So let's do a small recap, right? So the first step that we did was to read the data, right? After you have read the data, the next thing that you do is basically look at the info on the data. The info tells you what kind of variables you have, whether there are any missing values or not. After that, you basically look at the head or the tail as well as the columns, just to make sure all the columns have been read and all the columns have been read properly. Okay. Now, once you are sure so all of these, what we are doing is basically ensuring all the data that we have read are correct, right? So now at the end of this, we are sure that all of the data that we have read are correct. The next thing that we do is separate our data into categorical and numerical variables to be processed, right? So we separate our data into categorical and numerical variables. And then what we do is we start working on the numeric data first, right? So when we start working on the numeric data, the first thing that you do is basically look at some statistics on the numeric data, right? Example, you look at number of observations, number of missing, sum, mean, median, standard deviation, and percentiles, right? Now, what kind of observations can you get from here? You can do a lot of things, right? So for example, you can know which variables need to be treated for missing values, right? That's one primary observation that you can get from the first two columns. The second thing that you get to know is you get to know your variables better. And this is an extension with the question this other person had. So once you have got this sum, mean, median, the next step is to basically share these inputs with the business, right? Because if you're working on something, your analysis or the base of your analysis is your data. That data should be reflective of the actual scenario that is happening in the business, right? Say for example, let's say you are getting the mean width and the median width as 70 and 71, right? Now, it might happen that right now in the market, the business, the things that the business is seeing is most of the cars are now much wider, right? So most of the cars, what they might think is, my should have a width which is greater than 70, right? Maybe they say that the average width that we see of the new cars being launched is around 100. So if that's the case, it means that there is some problem in the data that you have collected, because your data is now not reflective of the actual scenario. Or for example, let's say the fuel capacity here or the fuel efficiency here shows an average of 23 and 24. And now let's say most of the cars have got very fuel efficient and the fuel efficiency has gone up, right? And the average fuel efficiency that the business now sees is around say 40, right? In that case, it will indicate that the data that we have selected is not reflective of the actual business case, right? So after getting this, so all of this is not done to just get a look and feel of the data, but rather to get a sign off from the business that the data that you are using is actually in sync with what they see. Because if this is not in sync, whatever analysis you do will not be also in sync, right? If my data is off from the actual scenario, the regression model that I will build will also be off from the actual scenario. And therefore the accuracy will also be off. So this output will basically ensure that whatever I'm seeing is it gets signed off by the business. Make sense? I mean, by business, I mean it might be the actual client, or it might also be a person with domain knowledge from your own team, right? It has to be signed off by one particular person who has domain knowledge. Okay. Now, this numeric summary can also be basically exported into Excel, and you can build a nice PPT around it and show it to the client. Okay. Make sense? Yeah. Okay. Great. Now, you can do the same thing around categorical variables as well. So for categorical variables, the primary things that we are interested in are whether it has missing values and what are the frequencies for each category, right? Say for example, one of the variables that we have is manufacturer. Now manufacturer has no missing values, and this output basically tells me what is the frequency of each value. For example, there are 11 cars in my database which are manufactured by Ford. There are 11 cars in my database which are manufactured by Dodge, right? So I need to get this signed off as well. Say for example, in my data, I see there are 11 Ford cars, but right now the dealership that I'm working with might have stopped selling Ford cars, right? So in that case, I need to remove these from my data set, right? So these things have to be signed off by the business. This portion that we are working on is known as EDA, or exploratory data analysis, right? We are just exploring the data that we have. And exploratory data analysis is usually followed by a business sign-off. So whatever you find in the exploration, the business should be in sync with whatever you have found. Make sense? Okay. Now, after you have done the exploratory finding, we also looked at one useful function, which is profile report, right? Profile report will basically do all of the things that we did manually by writing functions. So this works on the full data set, irrespective of categorical or numeric variables. And this will tell you, this will first show you warnings. Warnings are anomalies that are detected. And not only that, it will also show you individual statistics on each variable. We did this, right? This can be exported to a file, and you can show it to the business directly. You can show this file directly because it comes in a very friendly format. I mean, you don't need to format it in any way, right? This whole HTML file can be exported. Okay. HTML. Yeah. This is a HTML workbook, right? So it gets exported as HTML. Yes. So what you can do is you can assign these to X, right? And then if you do to file, a file will be written in your working directory. So this is the file which has been written. So if you open this file, this is the exploratory analysis. The whole analysis will be there. Okay, now after you have got a sign off from the business, the next thing that you do is you start with cleaning up of the data, right? Now you know that whatever sample you have collected is reflective of the business. You now start cleaning the data. So cleaning the data has primarily two parts. Getting rid of very large or very small values or outliers, and getting rid of missing values. Outlier treatment is usually, followed by the missing value treatment. Outlier treatment has to be done first. Can you tell me why? Yes, because in missing value treatment, we basically replace missing values by average, right? If we do not do the outlier treatment, the average value that we will calculate will be skewed, right? So that's why outlier treatment is done first, followed by the missing value treatment. Now, once you have done the outlier as well as the missing value treatment, what happens is you basically have a clean numeric data. Make sense? Okay. So let me run this. All of you have gone through these functions, right? I'm not again going through them. Okay. This does the missing value treatment. Yeah. Now, the next point on which we will focus is on categorical variable. So far, we were only working on numeric. So in categorical variable, one of the most important thing that you have to do is convert categorical variable into a numeric representation. A numeric representation basically means converting them to binary values, right? So what we will do is, we will basically use a function called pd.getDummies and pass the variable that we want to convert to dummies. This will create a new data frame which will have all the dummies, right? Now, after you have created the dummies, what pd.getDummies does is it will create as many dummies as there are categories, but mathematically we need one less, right? It is not mandatory that you drop one, but it is better that you drop one because you have less variable to worry about, right? So if you have 20 categorical variables, if you drop one variable for each dummy conversion, you have 20 less variables, right? Which is good, right? So that's why people always prefer to drop one. But having said that, it is not mandatory to drop one. If you don't drop it, it's your choice. Make sense? Okay. Now, another name of this dummy conversion is known as one-hot encoding, right? In machine learning, you will see this term many times, one-hot encoding. The reason it's called one-hot encoding is because one of the variables out of all the dummies for a given observation, one of the variables will be hot. Hot means it will take a value of 1, the rest of it will be cold, right? So if I convert, if say gender is a variable and I convert this to dummies, right? So how many dummies will I have? 2 dummies, gender underscore male and gender underscore female. For any given observation, only one of these variables will be hot. So either this will be 1 and this will be 0, or this will be 0 and this will be 1. That's why it's known as one hot encoding. Okay. Make sense? Okay. Now, although we are using this, but there are other ways of treating dummy variables as well, right? Which we will not work on. But if you are really interested in machine learning, you should explore them. Again, this is not part of the course, so you don't need to remember. Just FYI, something like this also exists. Another way to treat dummies is to replace each category with the average value of y. What you do is, so you have a y variable, right? Let's say, go to this car sales example. Let's take this vehicle type. This is a categorical variable. So let's take this type. Right? So let's put it in a different sheet and let's take the y as well. So what is my y here? Sales in thousands. So this is my y. What I'm saying is, so if we were converting to dummies, what will happen? There will be 2 dummies, vehicle type underscore passenger and vehicle type underscore car, right? And this will be 0 and 1 depending upon what value this takes, right? There's a third way which is used by some data scientists. What they do is they will calculate average value of y for each category. So how many categories are here? 2, right? So let's take distinct value of these categories. Okay. Then what I will do is calculate average. Okay. So this is the average value of sales when the car is a passenger type and when the car is a car type, right? What I will now do is I will create only one variable, which is vehicle type underscore converted, and this variable will basically take the average value if it is passenger and average value of y if it is car. Make sense? Right? Now, tell me, what is the advantage of doing this? And what is the disadvantage? Yeah, advantage is instead of many variables, you will only have one variable for one category, right? So your number of columns is much less. That's one. Anything else? You will only have continuous variables to deal with, right? You do not have a binary variable, right? These two are advantages. Disadvantage, any disadvantage of this? Disadvantage will be while interpretation, right? How will you interpret this variable? Yeah, a machine will basically, interpretation means human interpretation, right? So if you are explaining this variable to your client, how do you explain this variable? There is no way that will be explained this variable. Dummies can be explained because in the regression equation, you will see the dummies. You can then say if a vehicle is passenger type, it increases your sales. If a vehicle is a car type, it decreases your sales. You can say comment things like this. But if you have a variable which looks like this, you will not be able to interpret because this variable does not have any business interpretation. Do you understand? I mean, how do you interpret this variable? Right? So that's why this method is only used where interpretation is not a problem. I mean, you are not worried about interpretation, then and then only then you will use this method.
So what is this
Otherwise, you
method
will
called?
not use this method. Huh? Sorry?
What is this method called?
Oh, there is no name to it. There is no name to it.
So does it make any difference, this method versus dummy in my final output?
Yeah, the numbers will be different. Also, if you use this, your code will run much faster because the number of columns will be less. The codes will run much faster. The number of variables will be much less. So you have much less number of things to worry about if you use this. But then you will have a problem while interpreting the equation. And interpretation is a very important task.
Do we have any impact on the values of R square and p values?
Sorry, it will do what?
Do we have any impact on R square values and
They will be
p
different. They
values?
will be different. I mean, what do you mean by impact? Since we are using a different variables, we'll have a different R square and we'll have a different p value.
So in case of if we use the dummy method, if we get p value of say less than 5%, and
Oh, that I can't tell, right? That I can't tell. That depends on the data. It might be that these two were significant, but this variable might turn out to be not insignificant. That might happen. Right? Hmm. नहीं, machine क्या कहते हैं सर? Hmm. मशीन इसको इंटरप्रेट करने की जरूरत नहीं है. मशीन इसको एज ए न्यूमेरिक वेरिएबल पढ़ेगा. ये this is just like something like engine size, right? It's numeric. This variable is not categorical, right? This is numeric variable. So इसको as a numeric variable पढ़ेगा. Machine does not worry about interpretation. Yeah, you will drop vehicle type column and you will replace that with this column. Forty-three is the average value of sales for all cars who are of the type passenger. Similarly, 80 is the average value of sales for all cars who are car. Does it make sense? Now, this method, these kinds of methods are, there are a lot of methods. This is just an example. This kind of methods are basically developed not by statisticians, but by people who compete in competitions like Kaggle and all, right? So there's no theoretical background to it. It's just that this works. Cool. There's no name. That's why, right? So somebody, while you're working on a particular problem, saw that this works. So this works. There's no name to it. There's no name. Okay. Actually, this method is basically derived from another method which we will use later on, but this has no name. This has no name. Okay. Now let's come back to this, right? For now, forget about the second method, right? We will not use it. We'll only concentrate upon dummies. So once you have created the dummies, if you decide to drop one of them, it's fine. If you don't decide to drop one of them, that's also is absolutely fine. After you have created the dummies, you basically merge the numeric and the categorical data frames together to have one single clean data set. अभी के लिए आप सिर्फ 0 1 यूज करोगे. वो मैंने आपको बताया कि वो भी एग्जिस्ट करता है. अभी वो भूल जाओ. अभी सिर्फ डमी करेंगे. ठीक है. Okay. Next, once you have cleaned the data, the next thing that we are going to do is start looking at some of the assumptions, right? What was one of the assumptions in linear regression? One of the assumptions was that the y or the residual should follow normal distribution, right? So how do you, so for that, how did you detect whether it is normal or not? So one is QQ plot of the residual. Second, we talked about histogram of the y, right? So how do you plot a histogram? So to plot a histogram, what you do is you look at a module called Seaborn. Seaborn is a module used for plotting graphs. And within Seaborn, you look at a function or a method called dist plot, right? What dist plot does is it will take one single variable and give you the histogram of that variable, right? So this is the histogram of y. Make sense? SNS dot dist plot takes one variable, gives you the histogram. Histogram means frequency distribution or probability distribution.
So can you also tell the code for QQ plot in Python?
When we do it, we'll talk about it, right? So right now, let's talk about this. Okay. So you have got the dist plot, and you looking at this. Do you think it is normal? It's not normal, right? So what do you do if it is not normal? You try to take a log, right? Okay. So the next thing that we are going to do is we are going to try out by taking log. So we create one variable which is log of sales in thousands, right? We explained why I am doing +1, right? So it's not never 0. So if you run this, it creates a new variable in the data frame, right? Now if I again plot and get the histogram, now the distribution is much closer to a normal distribution. So from now on, the log of car sales is my y variable. Okay. Now, if log of car sales is my y variable, I need to drop the original one because otherwise this is an extra variable which is there. So I drop that variable from my data frame. The car, I'll be using log of car sales as my y, right? So I don't need the original car sales number, right? So I will drop that column. Okay? So I drop this column from the data frame and basically store it in a new data frame. Makes sense? Okay. Now this new data frame has these many columns, right? Because I have also created dummies, right? So number of columns have increased. Okay, now one of the critical things that we should do while building a regression equation is to select which variables are important and which variables are not important. Because here you might have, here you have less number of variables, right? It's like 15 or 16 variables. But in a practical scenario, you might have thousands of variables. So you cannot build a regression equation with 1000 variables. You need to reduce the number of variables, right? Why you can't build a regression equation with 1000 variables? One is adjusted R square. Second is, say out of 1000 variables, 99.99% case what will happen is 990 variables will become insignificant, right? Now what happens when you have an insignificant variable? What happens when you have an insignificant variable?
Difference between R double R and adjusted R increased.
So adjusted R, forget about adjusted R square and R square for now.
Okay,
Let's say adjusted
accuracy.
R square and R square are close. Let's take that example, right? Let's say they are close, right? And 990 variables out of 1000 variables have a p-value which is greater than 5%. What do you do when you have variables with p-value greater than 5%? We have to drop them one by one. Okay.
Okay.
To remove 990 variables, how many times we need to run the regression equation? 990 times, right? So you see what is the problem in having huge number of variables. You need to repeat the dropping process a huge number of times. So what people try to do is they only take important variables to regression equation. They will not take irrelevant variables to the regression equation because it will increase your headache. You need to drop those variables then one by one. So that's where I'm coming. You understand why we need to drop, right? Now, so this dropping process, or rather we call it selecting process, is known as feature selection, right? You are selecting features or variables which are important in predicting the value of y, right? Okay, now, what kind of variable is y in regression? What kind of variable is it? Is it categorical or continuous?
Continuous.
Continuous.
Continuous, right? And
Sir,
right now, all of our x variables are also numeric, right? So how can we measure relationship between two numeric variables?
Correlation.
Correlation, right? So what we will do is we will basically look at correlation between y and each of the x variables. Make sense? Okay. Now, how do you get that correlation? In pandas, there is a property or a method of data frames known as dot CORR, right? CORR. What this method does is this will give you correlation between each variable with every other. So if there are 20 numeric variables in your data frame, it will give you a 20 cross 20 matrix, which will have relationship between each variable with every other possible variable, right? So what I do is I
we will
run
not
this.
VIF.
Sorry,
VIF, we are not going to calculate it.
VIF is for multicollinearity. VIF is basically relationship between x and x. We are looking at relationship between y and x now.
Okay.
Okay, now
So sir, here we are looking relationship between y and x.
yeah, so that's what I'm saying, right? We will only keep variables which are most related to y.
How we can identify which is the most related? Is there any certain criteria that
That's what I'm trying to come to, right?
Okay. Okay.
Okay. So you have these correlation numbers, right? Now, out of this correlation matrix, the only area that we are interested in is basically the line which shows the relationship between y and the x variables, right? This is my y and this line shows me the relationship between y and every x variable, right? Okay, so this is the only line that I am interested in. Now, so what I will do is I will store this in a data frame, right? And once I store this, I can then write x. What was the name of this? So if I write this gives me the relationship between each of the variables with the y. This is the correlation between each variable and the y. Make sense? Okay. No?
Sir, can you explain this one? X is equals to car underscore sales new. That one data frame, and with that data frame, we are taking the correlation. That I.
So you understand what this matrix tells you? So here, 1 basically is the correlation between year resale value and year resale value. 0.83 is the correlation between year resale value and price in thousands. 0.44 is the correlation between year resale value and engine size. Now, what are we trying to do here? We are trying to figure out which variables are mostly related to y, right? What is my y here? My y is log of sales in thousands. This is my y now, right? So I am only interested in this line, right? I am not interested in the above lines, because this line gives me relationship between my y and every x.
So sir, here is my question. Is there any function or method which can create this relationship only between in sale and thousands y and x rather than creating a complete matrix of all the variables which are present?
I'm going there, right? Okay, so this gives you this is the last line that we are interested in, right? Now, how do we get rid of these junk values? Rest are junk values for me right now, right? How do we get rid of this? Now, this is a data frame, right? And these names of the variables are row indices. So how do you isolate one row in a particular data frame? By giving the row index. Okay, so what I do is I store this output in a variable x. Then I give the row index. Row index is name of the variable, right? Now if I run this, what are these numbers? So minus 0.47 is the correlation between year resale value and log of sales. Minus 0.56 is the correlation between price in thousands and log of sales. Make sense? No.
Yes.
Not really, not really. So what dot core does is dot core will give you correlation between every variable present in the data frame with every other variable. My data frame contains both x and y, right? So here, since this is a x, this gives you relationship between x and x. If I go to the row where my row is of y variable, then these values give me relationship between y and x, right? Other way to do it, you individually calculate correlation between each and x and y. That is manual, right? Why would you do that? This directly gives you the list. Mm-hmm. Here also we are doing the same thing. Here also we are doing the same thing. So you are not getting my point. My point is, so here, how many variables do we have? We have 16 variables, right? And out of that, one is y. So basically we have 15 variables. Now imagine instead of 15, you have 1500 variables. Let's say there were 1500 columns here. My point is, you cannot build a regression model with 1500 variables because we discussed what will happen. So what I need to do is, before I build the regression equation, I need to get rid of few variables, or basically select few variables. Getting rid means selecting some, right? So how do I select those variables, right? I select those variables by looking at the correlation of the variables with y. The higher the correlation, the more is the relationship, right? So now, if I have the correlation of every x variable with y, what I can do is I can then export this into a CSV. Okay, so once I export this into a CSV, so I can now look at this data into an Excel file and then basically decide which variables I need to use and which variable I can drop. So for example, oh, it has exported the whole thing. Just a second. I need to do this. Sorry. Okay. Yeah, I need to select the column. Yeah. Now, once I have this, I have now two columns. This column gives me X variable. This is the correlation. Now what I do is I calculate absolute value of correlation. Why? Because high negative and highly positive both are highly related, right? So I calculate the absolute value. And all of this you can also do it in Python, but it's easier to do it in Excel. Okay. Now then what I do is I sort them by their absolute value, largest to smallest. Now, the first one is actually the correlation between y and y. So I need to delete this, right? This is not a x variable. Now, next, these are the rank ordering of variables. Now, what is the most important x variable? Price in thousands, which makes sense. Sale of a car is highly dependent upon its price, right? Second is resale value. That's the next thing people consider, right? How much is the resale value? Third is the power. How much is the power of the car? Fourth is horsepower. Fifth are the dummy variable for Ford. Sixth is the vehicle type variable, and so on. Right? Now let's say how many variables I have? 41, including dummies, right? Now if I need to figure out which are the top 30 variables which are the best, what I can just do is select the top 30 from here. Makes sense? If you have 15,000 variables here, so you will have 15,000 rows. You can directly select the top 30 from here, and they are the best 30 variables out of everything that you have. Make sense?
Sir, can you please repeat how many variables should we select
No,
based
I'm not saying how many variables you are selecting, right? That
then
is
what
totally
should
dependent on how much you can handle,
okay.
right?
Okay.
I'm just saying if you want to select, say top 30, this is how you can select the top 30 because this
Okay.
gives you rank ordering, right? Once you rank order, then you can figure out that, okay, for the next step, I am fine with taking 50 variables or 30 variables, right? And then only select those. How many variables you take to the next step is totally dependent upon two things. A, how much capacity of data crunching you have. B, how much time you have. Because If you take 500 variables to the next step, you will take huge amount of time to process. If you take two less variables, your model will not be good. So if I just take one variable to the next step, right, my model will not be good, right, because I'm not using most of the information present. So this is, there's no fixed number to it, but what usually people do is they will usually take square root of k. If k is the number of variables, they usually take around square root of k to the next step, right? But having said that, if you only have 30 variables, you will take all 30, right? If you only have 50 variables, you will take all 50. This square root of k only comes into picture if you have greater than equal to 200 variables. Anything less than that, take the whole thing.
Sir, is this correlation value also matters? Sometimes we consider that, like greater than this value, greater than less value.
No, I mean, see, there is no threshold for correlation, because the correlation numbers might vary from one data to another. There is no threshold for correlation. Correlation is just used to rank order the variables, and then you decide how many variables you want to take to the next step.
Okay, because if you consider correlation concept, point one looks very weak correlation. So
Yeah,
it
right.
doesn't matter
That's
at
why
that
there is
stage.
threshold.
Sir, can we say, I mean,
Because it might happen that in a certain data set, the highest correlation that you get is 0.1.
Okay, okay.
That might happen, right? So then if you have a threshold of 0.5, you are not left with any variable.
Okay.
sir, can we say during selecting variables, we need to see the business requirement, what exactly we want to achieve, and accordingly we select the variable.
See, I mean, yeah, obviously there is often a requirement from the business, and they will say, for example, you will have to use engine size,
Right,
right? Then so obviously there is no possibility of removing this, right? Then you already
right,
have to select this. If
right.
that's the case, then there is no manual selection, right?
Okay,
If the business has, I am assuming the business has no choice of variables, then this is.
okay.
If the business tells you I need 4 variables in the equation, then to variable selection, why will you do it?
Mhm.
You will only build using the 4 variables.
Yeah, right. It depends
Right?
on the situation.
Yeah, it depends on the situation. Okay. Okay. So does it make sense? Yeah. Okay. Cool. Another interesting graph which is often built on these correlation numbers is heat map. Right. What is heat map? Heat map is basically a figurative way of representing correlation. Right. So it is basically representing the whole correlation matrix that we had seen before. What it is saying is deeper the color, higher the positive correlation. Higher the negative correlation. Lighter the color, higher the positive correlation. That's why you see diagonals are all light colored. Why? Because diagonals are correlation between one variable with its own, right? It will always be one. Make sense? But do we have any use of this? No. Multicollinearity we'll look at later. Right now, we will handle one problem at a time, right? So we'll first select which variables to take to the next step. Multicollinearity will worry later, right? Okay, so all of you understand this? This plot has no particular use. No use. I mean, yeah, okay, one use that you can get out of this is, say, for example, if you do something like this. I think I'll have to save it somewhere. 42. Oh, okay. Yeah, you cannot get it for a single line. Yeah, there is no particular use of this. There is no use of this particular plot. It looks nice, and that's about it. Okay. Any questions on what we are doing and why we are doing this? You're clear on why we are doing this? Okay. Now,
Yes.
for our case, since we only have how many? 40 variables. Since we only have 41 variables, right? We will carry forward with all 41, right? If it was much more, we would have selected few. Make sense? Okay. If you had 100, we will select say 30. Well, see, I say 30 because I am comfortable with 30 variables. If you have time, take 50. Best is take all 100 if you have a lot of time, right? Take all 100 and then explore all of them. Okay, now okay. So once you have selected the variables, right? The next thing to do is we will now verify another assumptions of linear regression, which is x variable should always be linearly related to y, right? There's an assumption, right? So we need to verify that. How do we verify that? Scatter plot, right? Scatter plot between each x and y. So what we will do is, for that we will use a method of the data frame called dot plot, right? What dot plot does is it will take two variables as input, one for the x coordinate, one for the y coordinate. It will take what kind of plot you want, right? And it will plot the graph. What is alpha? Is basically the contrast of the graph. So if I reduce the value of alpha, you'll see the graph will become very light colored. You almost can't see the points, right? So alpha is basically the contrast. Okay. Makes sense? Contrast of the graph. So for example, टीवी में contrast होता है ना, उसको कम कर दो तो कुछ नहीं दिखता है, बढ़ाओ तो clear होता है. This is contrast.
X and Y we can change it, right?
Yeah, so you can change x and y. So so this is how you basically need to look at each pair of x with y and figure out if the relationship is linear or not. Make sense?
But the other correlation, previous correlation we'll do, it is also telling same thing, no?
Sorry? Sorry, what? Okay. Yes. Obviously. So that's why, right? So we did the feature selection prior to this because we don't want to study the relationship for variables which we will not use. So after feature selection, whatever variables you have selected, you will only investigate them because you are taking them to the next step, right? Okay.
Sir, as we can see,
41 variables.
whenever you are plotting the graph, there is some warning is coming in red color.
I'm coming to that. Sorry, what?
Okay.
You're saying what? No. This is 1x versus y. You have to repeat this 41 times. So here I am plotting resale value versus my y, which is log of sales in thousands. I'm just looking at whether you can have whether the relationship between your resale value and sales is linear or not. Right? That's one of the hypotheses in linear, one of the assumptions in linear regression, right? So I need to verify that. Now, often what people do is instead of plotting as getting a scatter plot, they also want a line with it, right? So if you want a line with it, so you can get that by using SNS.lm plot. SNS is Seaborn. Within Seaborn, there is a function called LM plot, linear model plot. It takes again one X variable, one Y variable. It takes name of the data. It takes the aspect ratio and the alpha. Aspect ratio is rho is to height of the graph is to width of the graph, right? It takes the aspect ratio and the alpha. So if you run this, then you get a plot with the regression line built into it. This is for the whole data. Yeah, this is the whole data frame. Yeah. Sorry, you were saying what? No, this line is the regression line that would have been created if you create a univariate regression between this X and Y. So if I create a univariate model with this X and trying to predict this Y, I will get this regression equation. Scatter underscore KWS takes some graphical input. So here I give the value of alpha, which is the contrast. Okay, now there is another function called pair plot, right? What this will do is this will give you all possible graphs between all possible variables. So for example, instead of doing this 41 times, if you want to create all the plots at a single go, what you can do is you can use this. Can I explain what? Univariate means one variable. That's why this is a univariate regression. इसीलिए तो univariate बोल रहे हैं इसको. This is the univariate regression line. अगर आप एक regression model बनाते जिसमें आपके पास सिर्फ ये variable as a x होता and इसको use करके y को predict करने की कोशिश करते आप, तो जो regression line बनता वो ये है. तो ये क्यों यूज होता है? ये इसीलिए यूज होता है, ये जो लाइन है, अगर ये लाइन आपको देख के लगे कि दिस इज जस्टिफाइंग मोस्ट ऑफ द एक्चुअल पॉइंट्स, देन यू नो दैट x एंड y आर लीनियरली रिलेटेड. अगर लाइन यहाँ पे है और पॉइंट्स कहीं और जाके स्कैटर्ड है, तो देन यू नो दैट x एंड y आर नॉट लीनियरली रिलेटेड. इसमें है ना, मोस्ट ऑफ द पॉइंट्स आप देखो यहाँ पे आजू बाजू रह रहे हैं, पर ये थोड़ा सब्जेक्टिव है, राइट? दैट्स व्हाट आई सेड, राइट? इफ इट इज नॉट मार्क्डली नॉन लीनियर, यू विल एज्यूम दिस एज लीनियर. लास्ट क्लास में हमने डिस्कस किया था कि अगर आपको देख के नहीं लगता है कि ये तो लीनियर हो ही नहीं सकता है, तो आप लीनियर मान लोगे. इफ इट इज नॉट मार्क्डली नॉन लीनियर. ठीक है? क्या कहाँ जिगजैग कहाँ दिख रहा है? यहाँ पे बल्क ऑफ द ऑब्जर्वेशंस यहीं पे आ गया ना. एक आध ऑब्जर्वेशन यहाँ पे कितने ऑब्जर्वेशंस है? बहुत कम है, राइट? बल्क ऑफ द ऑब्जर्वेशंस आर हियर.
Increase the alpha, then it will get visualized.
Sorry?
Alpha, you can increase the alpha, then it will be more visualized.
हाँ, actually I have this SNS square plot running. Sorry, you didn't answer your question. So most of the observations are here, right? So this line justifies most of the observations. One or two observations to either हो गए, because no relationship is perfectly linear, right? So you are trying to look at a case where the line justifies most of the observations. क्या? हाँ. लॉग लेके देख सकते हो, if it makes things better. हाँ. If you think that let's say this is not linear as per you, right? Then take a log of this and try to create a plot which is similar. If then you think it is much more linear, then use the log, right? मेरे हिसाब से this is linear enough. Okay. Okay. अभी ये तो रन ही हो जा रहा है. Okay. Any questions? I'll wait for this to finish. This is actually creating 41 into 41 plots, so that's why this is taking so long. Yeah, so any question? Regression line जैसे create होता है सर, वैसे ही create होगा. Regression एक line create करता है ना.
So sir, we have to repeat like this one. We have.
आपने कभी Excel में scatter plot किया है? किया है ना? Okay. कहीं पे किया है scatter plot? हाँ, कहीं पे तो किया होगा. 1 second. हाँ, नहीं. जैसे ये है और ये है प्राइस इन, एक वैल्यू ले लेते हैं जिसमें मिसिंग नहीं है. I don't want to do the missing value treatment right now. सब में मिसिंग है क्या? Okay, let's take length, right? तो ये है y, ये है x, है ना? So if I get a scatter plot of this, ऐसे दिखता है scatter plot, okay? भी Excel में if you right click, there is an option called add trend line, है ना? ये आप add trend line करोगे, यहाँ पे ऑप्शन आता है exponential, linear, logarithmic, ये वो, ठीक है? यहाँ पे अगर आप linear select करके क्लोज करते हो इसको, ये जो लाइन बनता है ना, वो लाइन एग्जैक्टली ये है. तो ये लाइन का है क्या? 1 सेकेंड. ये जो लाइन है ये बेसिकली ये लाइन है. ये लाइन ये इक्वेशन से आता है. What you are just trying to do is you have a x variable, you only use that x variable to predict y. Univariate regression बनाते हो. तो ये जो univariate regression से जो आउटपुट आता है that is this line. अगर most of the points ये लाइन के आजू बाजू है, मतलब क्या है कि x and y are linearly related, है ना? तो इसीलिए हमने वो लाइन वहां पे ड्रॉ किया just to see कि most of the points are in and around that line or not. हाँ, a univariate regression will just look like mx plus c. Okay. 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 Before we do that, right? Okay. I will not be able to get this plot, right? Because it's a huge plot. It says that the data rate has exceeded. So, I mean, getting that plot is not suggested if you have a large number of variables. 41 plus 41 means how many plots? 1600.
Around 1600.
Right? 1600 plus plots आप मैनुअली तो इंटरप्रेट कर नहीं पाओगे ना. तो इससे अच्छा ये है कि एक एक करके यहाँ पे 41 प्लॉट्स डाल दो, है ना? 1600 प्लस 1600 प्लॉट्स इतना ह्यूज होगा ना, उसमें छोटे छोटे इतने प्लॉट्स आएंगे आप देख नहीं पाओगे. एग्जैक्टली. तो आपको एक एग्जांपल दिखाता हूँ. जो हमने वो मार्केटिंग का मार्केट मिक्स मॉडल किया था ना, उसमें कितने वेरिएबल्स थे? 3 x थे, 1 y था, है ना? उसका तो 4 वेरिएबल्स टोटल थे. तो उसका उस डेटा सेट पे अगर आप ये पेयर प्लॉट करोगे ना तो 4x4 आता है. 4x4 में यू कैन स्टिल इंटरप्रेट समथिंग. 41x41 में आपको कुछ इंटरप्रेट करने को दिखेगा नहीं. तो अगर लार्ज नंबर ऑफ वेरिएबल्स है तो एक एक करके ही करना ज्यादा इजी है. Make sense? So if you run the same command, you will get a plot like this, which is basically all possible scatter plots. Okay.
अगर इस एग्जांपल पे जाएंगे, वो 4 जो ग्राफ आ रहा है, फर्स्ट में हिस्टोग्राम है एंड सेकंड में स्कैटर, थर्ड डिफरेंस क्या है हर एक प्लॉट में? टीवी के लिए जो लेट्स अज्यूम टीवी के लिए हम एग्जांपल लेते हैं,
कहाँ पे जाऊँ?
ये जो पिछले वो जो एग्जांपल आपने कर रहा पीछे वो 5 सेकंड वन एडवर्टाइजमेंट वाला जो आपने एग्जांपल पेयर प्लॉट जहाँ बता रहे
हाँ, अच्छा आप एक बात बताओ, do you understand that this plot and the next plot are the same one? ये सेम ही डेटा पे है ना? हाँ, मैंने यहाँ पे क्या किया, एक्स्ट्रा लाइन डाला है. अगर आपको लगता है कि लाइन डालना जरूरी नहीं है, then if you can only interpret from this plot, then you can only use this plot. Oh, okay. मैं क्या करता हूँ, मैं जहाँ पे ज्यादा पॉइंट्स है, I try to pass a line through that, right? Or say something like this. अगर मैं एक लाइन यहाँ पे ढूंढ पाऊँ which explains most of these points, then from this graph I know that it is linear. वो interpretation. पर अगर I mean this will again come with a bit of time, right? अगर if you do not feel comfortable that, or if you are not able to visualize that line, I would recommend go with the next one जहाँ पे line आ जाता है ना? कुछ if you are comfortable enough without that line, then use this plot. You need the line, use the next plot. Yes. Okay. Now, one of the question was how do you interpret this, right? The interpretation is diagonal में हो गई histogram, ठीक है? क्योंकि x versus x तो scatter नहीं हो सकता है ना, वो histogram बनेगा. All the diagonal plots are histogram. All the off diagonal plots are actually the scatter plot. ठीक है? It's just like the correlation matrix. Correlation matrix में भी diagonal में सारे 1 थे ना. यहाँ पे भी अगर आप देखोगे, so for example, if I look at this plot has TV in the y-axis, and if you look at the x-axis, it has sales in the x-axis. So if my y variable is sales, then I can say TV and sales are linearly related because you see this is almost perfectly linear, है ना? तो इस तरीके से you can interpret this graphs. But you can only use the pair plot if you have less number of variables. Otherwise ये plots ना बहुत छोटे हो जाएंगे, तो interpret कुछ कर नहीं पाओगे आप.
सर स्कैटर प्लॉट के लिए तो क्लियर है, लीनियरिटी चेक हो गया, और हिस्टोग्राम के लिए क्या वो वही एक तरह से बेल कर्व अगर आ गया तो अंडरस्टैंड?
हिस्टोग्राम का स्पेसिफिक कोई इंटरप्रिटेशन नहीं है. आप मतलब मैक्सिमम ये देख सकते हो कि आपका जो y है यहाँ पे उसका हिस्टोग्राम नॉर्मलिटी फॉलो कर रहा है कि नहीं.
ओके.
What were you saying? You cannot select the graphs. No, not using this method. Pair plot, जो भी variables है सबका pair करेगा. So से कितने को यहाँ पे हमने 41 select किया है ना, तो फिर कितने प्लॉट्स बनेंगे? 41 क्रॉस 41, which is huge, right? You can't see anything. और आपने 10 भी सिलेक्ट कर लिए वेरिएबल्स, तो कितने प्लॉट्स बनेंगे? 100 भी आप कुछ देख नहीं पाओगे. Instead of doing that pair plot, if you have more than say 5 variables, do this, right? Anyways आपको इंटरप्रेट तो एक एक ग्राफ ही करना है ना. आप 100 ग्राफ एक साथ तो इंटरप्रेट कर नहीं पाओगे, करोगे तो एक एक करके. तो एक लाइन रन करने में क्या जाता है? Okay, so this basically has to be done 41 times, and you need to figure out okay, if any of these variables are not linearly related. Yeah? So for now, we will assume that everything is linearly related. Okay. Now, if everything is linearly related, the next thing that we will do is we will split the data into 2 parts. One for developing the model, second for testing the model, right?
Sir,
Why do we do that?
question, sir.
Yeah.
So what about the other assumptions that heteroviscosity and all you explained?
For that we will do that, right? So for that so for example heteroscedasticity के लिए आपको क्या चाहिए? एरर कब मिलेगा? मॉडल बनाने के बाद. तो मॉडल पहले बनाना पड़ेगा ना.
Okay.
Why do we split the data into two parts?
To select the data for training and testing.
Yes. So basically what we'll do is we separate the data into two parts, one which we'll use for development, second which we'll use for testing. Before we do that, what we need to first identify is which are my X variables and which is Y. Y do we know? It is log of sales in thousands. How do I get my X variables? I get my X variables by just writing cart sales underscore new dot columns. This gives me list of all the columns, right? From that, if I remove my Y, what I am left with? All the X. So this feature columns is my X variables. This is my Y variable. Clear? Okay. Now,
Difference is a keyword, right?
difference is the keyword. This method of a list. Yes.
Okay.
Sorry. What do you mean by multiple columns? नहीं वो तो ड्रॉप कर दिया ना पहले ही. Sales in thousands. Once we took a log, we dropped the original sales in thousands. ना? अभी क्या कर रहे हैं हम? बस नाम उठा रहे कॉलम का. नाम चाहिए ना कौन एक्स वेरिएबल्स के नाम क्या है और वाई वेरिएबल का नाम क्या है. एक्स डेटा से अगर वाई हटा दोगे क्या बचा? एक्स. तो ये जो फीचर कॉलम्स है ये एक्स वेरिएबल्स के नाम है और ये जो लॉग ऑफ सेल्स इन थाउजेंड्स है ये हमारा वाई वेरिएबल है. ये हमको क्यों चाहिए? ये इसीलिए चाहिए क्योंकि to build a linear model we need two kinds of data set. One which will have y, second which will have all the x. So we need to separate the data set into two parts, one with y, one with x. Now we also need to separate between training and testing. So how many data sets do I need? 4. One for training x, one for training y, one for testing x, one for testing y. Clear? 4 data set हमको चाहिए. ठीक है? तो 4 data set, how will we build that? What I write is this will be done using this method in sklearn.cross validation. sklearn एक module है, scikit-learn, right? Within that there is a sub module called cross validation. Within that there is a method or a function called train_test_split. sklearn.cross validation, उसके अंदर there is a function called train_test_split. For people who are using Python 2.7, instead of sklearn.cross validation, you need to use sklearn.model selection. उनके लिए नाम different है. ठीक है? अगर आप 2.7 यूज कर रहे हो, if you are using 3 then this will work. Okay, now so this function helps me to split my data into 4 parts. Now ये function के लिए हमको क्या चाहिए? इसके लिए we will have to pass a data frame with all values of x. x के नाम से यहाँ पे मैंने उठा लिए थे ना फीचर कॉलम में, तो यहाँ पे अगर ये मैं पास करूंगा तो ये जो डेटा फ्रेम है इसमें सिर्फ x होंगे, right? Then it will also need a data frame with the y values, right? So x और y को हमने separate कर दिया है. Then it will need how much data or what percentage of data should be in testing. So I'm doing 70-30 now, so 30% in the data, and then it will need a random state. Random state seed होता है, हमने discuss किया ना seed. Okay, so random state क्या होता है? So random state is basically known as seed. ये करता क्या है? All of you, we discussed random sampling, right? या तो रैंडम सैम्पलिंग में क्या करते हो आप, रैंडमली ऑब्जर्वेशंस उठाते हो, है ना। तो रैंडम सैम्पलिंग अगर आप हर बारी नया नया तरीके से करोगे, हर बारी ऑब्जर्वेशंस अलग अलग आएंगे, है ना। पर आप जब मॉडल बना रहे हो, यू आइडियली शुड फिक्स द डेवलपमेंट एंड द टेस्टिंग डेटा। एक बारी सैम्पलिंग हो गया, उसके बाद जितनी बार भी रन करोगे सेम डेटा आना चाहिए। अगर चेंज हो गया तो क्या होगा, आपके बीटा वैल्यूज थोड़े इधर उधर होते रहेंगे, है ना। तो आप यू वुड आइडियली वांट टू फ्रीज दैट डेटा। सो रैंडम स्टेट बेसिकली फ्रीजेस दैट डेटा। रैंडम स्टेट takes any number, give any number of your choice, right? But once you give it, do not change it, right? What it does is, given a random state, the first time when you run this sample, it does simple random sampling without replacement, right? The next time, as many times as you run this, it will get the same data, right? It will not change the observation. It does only random sampling once. Once it is done, then no matter how many times you run, you basically get the same set of observations in each of the data. मतलब क्या है, अगर एक बंदा है उसका नाम है ए, अगर वो फर्स्ट टाइम रन करने पे ट्रेन एक्स पे गया, तो जितनी बार भी रन करोगे वो ट्रेन एक्स में ही जाएगा, until and unless you change the random seed. तो उससे क्या होगा, हमारा सैंपल फ्रीज हो जाता है। उससे क्या होगा, आपका एनालिसिस रेप्लिकेबल होता है, जितने बार ही रन करोगे सेम आउटपुट आएगा। मेक सेंस? तो ये है रैंडम स्टेट का काम। ये रैंडम स्टेट याद कर लो आप, ये बहुत बार ही नेक्स्ट बहुत सारे एनालिसिस में ही दिखेंगे। जहां पे भी सैम्पलिंग होगा ना, वहां पे हमने रैंडम स्टेट फिक्स करना है, नहीं तो हर बारी रन करने पे अलग अलग रिजल्ट आएगा। मेक सेंस? Okay, so once you run this train test split, you basically get 4 data sets: train X, train Y, test X, test Y, right? तो आपके पास टोटल कितने डेटा थे? If you look at car sales, so you had 157 rows and 42 columns. 41 X variables थे, एक Y था, ठीक है? Now if I look at the shape of train X, train X में 70% of 157 is 109. उसमें 109 ऑब्जर्वेशंस गए और 41 X वेरिएबल्स चले गए। सिमिलरली अगर टेस्ट X का टेस्ट करोगे, उसमें बाकी गए होंगे। टेस्ट X में 48 गए।
Sir, by writing test size equal to 0.3, it by default take the train as a 70%.
हाँ, टेस्ट को 100% में 30% हटा दिया तो बाकी तो 70% बचेगा ना।
Okay. And sir, how that features column code work? Can you just explain again the features column you got?
Okay. What does sales? So when I run this, so have you all studied lists? List study किया ना? List. तो ये क्या करता है? List of column names देता है ना? Okay. तो list का एक मेथड है डिफरेंस। डिफरेंस क्या करेगा? वो वैल्यू को हटा देगा। तो बस मैं यहाँ से कारसेल्स डॉट कॉलम्स में 2 टाइप के वेरिएबल है, x है और y है। y मेरा एक ही है, y को हटा दिया तो क्या बचा? x बचेगा। तो यहाँ से मैं y का जो नाम है वो मेरे को पता है, वो मैं हटा दूंगा यहाँ से। तो मेरे पास जितने भी बचे क्या हुआ? अच्छा, इसको पास करना पड़ेगा, इसको लिस्ट में पास करना पड़ेगा। तो y हट गया तो ये x बचा।
Okay. So we are just removing y variable here.
We are removing y variables so that we get the names of the x variables.
X variables. Okay, thank you.
है ना? Okay. All of you are clear till here? तो यहां तक हमने क्या क्या किया है? यहां तक हमने डेटा इंपोर्ट कर लिया है। नेक्स्ट हमने डेटा चेक कर लिया है। चेक हमने कैसे किया है, एक तो हमने इन्फो रन किया उस पे, दूसरा हेड किया, तीसरा हमने उसका मीन, हमने बेसिकली उसका बेसिक स्टैट्स चेक किया है ना, वी चेक्ड ऑल ऑफ दिस राइट। देन हमने क्या किया है, उसको क्लीन किया। क्लीन में क्या क्या करते हैं हम, क्लीन में पहले तो हम सेपरेट करते हैं कैटेगरिकल एंड न्यूमेरिकल, ये दोनों हमने सेपरेट कर लिया। उसके बाद क्या करेंगे, जो न्यूमेरिक वेरिएबल है उस पे हम करेंगे दो चीज, मिसिंग वैल्यू एंड आउटलायर। सॉरी, पहले आउटलायर करेंगे, उसके बाद मिसिंग वैल्यू करेंगे। क्यों करेंगे पता है ना सबको? अगर नहीं पता है तो बताना है, बाद में जाके क्वेश्चन नहीं करने का। ओके, कैटेगरिकल, कैटेगरिकल में what we have done is we have basically, I mean categorical में if you have missing value, जो हमने किया नहीं है क्योंकि हमारा missing value थे नहीं, अगर missing value है तो replace by mode, ठीक है, क्योंकि हमारा नहीं था तो what we did was we created dummies, ठीक है। after that we combined, खैर combination भी cleaning में ही आएगा, we have combined categorical and numerical data, ठीक है। तो ये करने के बाद आफ्टर ऑल ऑफ दिस वी हैव अ क्लीन डेटा, है ना। तो ये हमारा डेटा क्लींजिंग हो गया। अभी क्लीनिंग के बाद हम क्या करेंगे, हम क्योंकि लीनियर रिग्रेशन ही बना रहे हैं उसके assumptions टेस्ट करेंगे, राइट। दो assumptions हैं जो हम टेस्ट कर सकते हैं मॉडल बनाने से पहले। वो दो assumptions क्या क्या है। फर्स्ट assumption that we tested is y follows assumption testing, right? So assumption testing में first क्या है, y follows normal, right? इसको हमने टेस्ट किया हिस्टोग्राम से। हिस्टोग्राम हमने कैसे बनाया, sns.displot, इससे हमने हिस्टोग्राम बनाया, ठीक है। नेक्स्ट हमने टेस्ट किया रिलेशनशिप x and y. Oh, okay, I missed one thing, sorry, assumption से पहले भी हमने फीचर सिलेक्शन किया है ना। फीचर सिलेक्शन में हमने क्या किया, हमने किया डेटा फ्रेम डॉट कॉर किया, है ना। तो इससे क्या हुआ, हमारा ऑल पॉसिबल कोरिलेशंस आ गया। देन व्हाट वी डिड इज वी टुक ओनली कोरिलेशन बिटवीन x एंड y। x और x के बीच में कोरिलेशन हम नहीं देख रहे हैं, x और y के बीच में देख रहे हैं, ठीक है। तो x और y का जो रो है सिर्फ उसी को उठाया हमने। and what we can do is identify important variables, which means they have high absolute value of correlation, है ना। correlation का ऐसा कोई threshold नहीं है, right? correlation is only used to rank order। उसके बाद you decide कि आपको कितने variables लेके जाने हैं, ठीक है। कोई गाइडलाइन नहीं है। अगर बहुत ज्यादा है तो स्क्वायर रूट ऑफ के यूज करते हैं। स्क्वायर रूट ऑफ के तभी यूज करोगे जब आपके पास वेरिएबल्स 200 से ज्यादा है, मतलब ज्यादा मतलब 201 पे भी यूज नहीं करोगे, बहुत ज्यादा है, 1000 है ना, 2000 है, देन स्क्वायर रूट ऑफ है, ठीक है। ओके, मतलब 100-200 पे आपको पूरा लेके जाना है, ठीक है।
अच्छा, एजम्पशन टेस्टिंग में अगर वाई फॉलो नहीं करता नॉर्मल को तो लॉग लेंगे,
वाई अगर फॉलो नहीं करता है तो लॉग लेंगे, राइट। ओके, नाउ नेक्स्ट इज रिलेशनशिप बिटवीन x एंड y। तो यहाँ पे हम सिर्फ उसी x के साथ रिलेशनशिप टेस्ट करेंगे जो यहां से सिलेक्ट होके आया है। यहां से अगर हट गया है तो नहीं टेस्ट करेंगे. That's why feature selection is done prior to this, है ना. अगर 1500 वेरिएबल है तो 1500 पे नहीं टेस्ट करना है. यहां से सिलेक्ट करेंगे 40, 50, 100 जो भी है, सिर्फ उसी पे टेस्ट करना है. मेक सेंस क्या? Not really. Feature selection can precede all of this. See, feature selection has nothing to do with this assumption, right? Yeah, I mean, so this log y, whatever you do with y has nothing to do with, okay, yeah, so you need to take log of y, okay, yeah, got it, got it, got it. So this assumption testing has to be done before. Sorry. Right, so first is you test whether y follows normal. If not, take log of y, right? Then you do feature selection. Okay. Now, uske baad what we did was we looked at assumption 2. Assumption 2 is relationship between x and y. इसको हमने कैसे देखा? इसको you can do two things. Either you write df dot plot, you know, then आप x और y दे दो उसको, एंड आप एक वैल्यू ऑफ अल्फा दे दो तो वो प्लॉट कर देगा. ठीक है, ये सिर्फ स्कैटर प्लॉट करेगा विदाउट द लाइन. इफ यू वांट टू गेट दैट लाइन यू नीड टू यूज sns dot think lm plot, right? Here you need to give x y, एक एस्पेक्ट रेशियो है उसको दे सकते हो आप, नहीं दोगे तो बाय डिफॉल्ट ले लेगा कुछ, राइट. एंड अल्फा भी ऑप्शनल है, ऐसा नहीं है कि अल्फा देना ही है. इफ यू वांट टू गिव अ कॉन्ट्रास्ट गिव इट, अदरवाइज इट्स फाइन. तो इससे क्या मिलेगा आपको? यू गेट अ लाइन अलोंग विद दिस स्कैटर प्लॉट व्हिच sometimes makes it easier to figure out whether x and y are linearly related or not, right? Okay, now अभी हमने दो assumptions टेस्ट कर लिए, 5 में से 3 अभी बाकी है, right? But those 3 can only be tested because you see rest of the 3 assumptions are basically on residuals, right? So residuals can only happen once you have the predicted. So predicted can only happen once you build the model. तो मॉडल अभी बनाना पड़ेगा हमको. तो मॉडल बनाने के लिए फर्स्ट थिंग दैट वी डू इज आइडेंटिफाई x. x हमने आइडेंटिफाई कर लिया हमारे डेटा सेट से, y हटा दोगे बाकी सारे x है. Then what we do is then we split the data into training and testing. Clear? Okay. इसमें से कोई पॉइंट है which you are not following, which you want me to repeat? Right. K fold क्रॉस वैलिडेशन कर सकते हैं. What is? तो if k is the number of variables, अगर k 1500 है तो आपको स्क्वायर रूट ऑफ k लेना चाहिए. k is the number of variables.
सर जो भी कैलकुलेट करना होगा हमें डेटा से, दैट विल बी द y.
Linearity we will not check using the correlation because correlation, like I said, gives you a binary picture, binary or two variable picture. Correlation सिर्फ एक x और दूसरे x के साथ you can calculate, right? You cannot calculate correlation between one x and all other x. So we will rather use a VIF for that.
Sir, whatever
only built after you're building model. Yeah, sorry, what was the question from online?
whatever we need to calculate, that should be the y, right? Indeed.
Whatever you need to predict, that is your y.
Okay.
नॉर्मली अगर 100 से ऊपर भी डेटा है तो डेवलपमेंट टेस्टिंग ही करते हैं, के फोल्ड नहीं करते. अगर 20-25 डेटा पॉइंट है तो के फोल्ड. Okay. Any other question?
Sir, we identify the X and remove the Y. If we will not remove the Y from the data, then what will happen?
नहीं, मैंने y को रिमूव नहीं किया है.
You have deleted the Y. I mean,
नहीं, डिलीट नहीं किया. ये नाम से हटाए हैं सर. मेरे को बस x वेरिएबल्स के नाम चाहिए. तो मैंने जो नाम के लिस्ट है वहां से y को हटा दिया, तो बाकी तो x के नाम बचे ना. y
Right.
वेरिएबल को मैंने हटा नहीं है, मेरे को बस x के वेरिएबल्स के नाम चाहिए.
okay, ठीक है, clear हो.
Okay. Any questions on this? Yeah? Okay. Cool. So now let's do one thing. Let's take a break now. Let's take a 15 minutes break, and we will start around 4. Let's get started. Huh? Let's get started. Okay. Now, once we have separated the data into training and testing, the next step is to basically go ahead and build a linear regression model. Linear regression model in Python can be built in 3 ways. The output is same, but there are 3 methods that you can use to build a linear regression model. One method is known as stats model .api. Second method is in stats model .formula API. Third model is in scikit-learn. Right? You can build linear regression by using any of these. They will give you the exact same output. I mean, in terms of the equation, they will build the same equation, but they differ in terms of how the output looks like, as well as how they look into the data, right? The output is exactly the same. I mean, in terms of the equation, they'll exactly build the same equation, but they are different in terms of their outputs as well as how they read the data. Now, so we will first understand stat models.api, then we will look at stats model.formula API, then we will look at scikit-learn, right? Okay, now let's first build the linear regression model with stats model.api. Now for that, we need to import stats model.api, right? And within that, the function that we will be using is OLS. OLS stands for ordinary least squares. Okay, so the format of the function is you write stats model.api.ols, right? And then you pass the train y and the train x. And then you write .fit. .fit is a method that you will see all across in almost all machine learning algorithms. .fit basically means you are actually training the model, right? If I do not write .fit, it will not train the model. It will only create an object of the OLS type. It will not train the model. Until and unless you write .fit, the model is not trained. So .fit here basically trains the model. It's a method. Trains मतलब the model का beta estimate करता है. Okay. Now, once we have trained the model, the next thing is to look at the output from that model, right? So the output is basically generated by writing name of the model dot summary. This will give us the output. If I run this, you will see that this gives me the output, which looks very similar to output that we have seen in Excel, right? So for example, it starts with what is the dependent variable, which is log of sales in thousands. Then it tells us what is the method it has used. It has used ordinary least squares. Method is least squares, then date, time, etc., etc. Number of observations is 109. Then it gives us the degrees of freedom of residuals. Remember the ANOVA table? Degrees, it does not draw the ANOVA table, but it gives you all the metrics. It gives you degrees of freedom of the residual. It gives you degree of freedom of the model. We had how many X variables? 41. So what is the degree of freedom of the model? 41 minus 1, right? So number of observation 109, number of degrees of freedom in a model is 40. So what is the residual degrees of freedom? 69. Okay. Now, so then it also gives us the R square. R square is really high, 96.6%, right? It also gives us the adjusted R square, which is 95%, which is more or less close to 96, right? Okay. Then it gives us the F statistic and the P value. This F statistic and the P value are corresponding to the ANOVA table, right? This P value is the P value from the ANOVA table. If this is greater than 5%, it means that all the beta values of your variables are equal to 0. Since it is less than 5%, it means that at least one is not 0. Makes sense? Okay. Now, then it gives you three more things. One is log likelihood. Log likelihood is not important in linear regression. We will look at this in logistic. Okay. Then it gives you two things, AIC and BIC, right? We will come back to AIC and BIC in a bit. Okay. Just hold on. Now, moving on, after you have seen this P value, if P value is less than 5%, and you then look at the P value for each and every individual variables, right? This is the P value for each and every individual variable. You need to remove variables with a P value greater than 5%. Right? There will be a lot of variables like that, right? So for example, most of the variables are like that. Yeah. Most of the variables are like that. Yeah. So if you need to remove them, how do you remove this? So out of all these variables, which one should I remove? Which has the highest P value, which is this. Right? This is a P value of 98%. Do you agree with this? Yeah? This is the highest P value. So I will remove this first, rebuild the model, and then again recalculate the P values, right? So let's do this, right? So let's say I remove this. How do I remove this? It's very simple. I will add this in the difference. Now, that variable has been removed. Now, let's see. There are still variables which is greater than 5%, right? Now, which is the highest one? Manufacturer audit. So you need to repeat this. Volvo is there. Yeah, okay. Yeah, so you need to repeat this process. I'm not doing this, right? So you need to repeat this process maybe 15-20 times, after which every variable will be less than 5%. And you understand? Okay. So this has to be done repetitively. Now, there are few more metrics which come out as part of this output. One of them is Darwin-Watson, right? What is Darwin-Watson used for? VIF बताता है.
Checking autocorrelation.
Autocorrelation. It is used to test autocorrelation. Now, what is the criteria? Close to 2, right? So here we have a value 2.15, which is fair enough, close to 2. So we will understand that there is no autocorrelation. So we have tested 3 hypotheses. Okay, there are 2 more that remain. Make sense? Okay. Now, apart from that, there are few more statistics which are displayed, which is skewness, kurtosis, and so on, which are not important. Right? The only thing that is important in this is Darwin-Watson. Make sense? Okay. Now,
Sir, what is omnibus?
omnibus is a statistic. I don't know what it does. I don't think these are important.
Okay.
Okay. Cool. Yeah. Next, the logistic. So, what is the name of the model that we have built? It is LM, right? If you check the type will be a regression type model. This data type is a regression type model. Now, this data type or this object has few methods which are very useful, right? Now, what for example, one of the methods that it has basically gives you, for example, so let me do a dir lm, right? Now, if I look at all the methods that are available, the method that I am interested in is test. Okay, just give me a second. P. Okay, so let's say if I do t test. Okay. Not this one. What I'm looking for is okay. This gives me the t value. Oh, there is a p value. Sorry. Yeah. Now, LM within this LM object, there is a method called lm.p values, right? What this gives me is this gives me the p values corresponding to each of these variables, right? You understand this is just a print, right? You cannot access these values directly until and unless you use lm.p values. Now, why do I need to access these p values? I need to access these p values if I need to automate the variable dropping process, right? So instead of say here, I drop one variable, but still I see most of the variables are still greater than 5%. I might have to repeat this process 10, 15 times. But why would I do it manually? Because the criteria is fixed, right? If you have anything greater than 5%, you need to drop the highest one, right? The criteria is fixed. So if you can get these p values in a list, can you find out which is the variable that has the highest p value? You can find that out,
Yes.
right? Now, once you know that variable, what you can do is you can straight away drop that variable from the list and you can run a loop, right? You can run a loop, and what that loop will do is it will give you the list of variables which are significant so that you do not need to manually repeat the whole process. Make sense? So that's one of the reasons. The second, apart from that, there are also hell lot of values that you can see from here, right? Say for example, if I want to look at the p-value of the ANOVA model, right? The ANOVA test which has been done, if I want to look at the p-value of that, it is f underscore p-value, right? If I write f underscore p-value, it will give me the p-value of the ANOVA test. If you need to automate the regression building process, these methods will come in handy. Do you understand? Yeah. Okay. Now, is this clear? Any questions?
Sir,
Okay.
can you please repeat this Durbin-Watson assumption you told right now?
Yeah. So Durbin-Watson, if the value is close to 2, it means there is no autocorrelation.
Okay.
Sir, we have other statistics on the above table, right? Like t-test, we have a coefficient, and we have others. So what they meant, like we have a this last two tables, last two columns we are getting. What they meant, 0.975%.
It is 95% confidence interval. You were also getting this in Excel, right?
Okay, so it is some 25% and 95%. What this, sir?
Okay.
Can you explain this a bit?
I did. You need to pay some bit of attention, right?
Sure.
So this is 95% confidence interval of the betas. So the betas that you have estimated is based on a sample, right? Now, if you change the sample, these betas will change. So if I again collect another sample, the betas will change, right? What this interval tells is, if you collect 100 random samples, 95% of those cases, you will have this beta bit within this interval. If I keep on collecting the sample, my betas will fluctuate, but 95 out of 100 times, the beta will be within this particular range.
Okay.
Any other question?
And so this t-test, is there any meaningful here of the t-test and standard error in the table?
P and standard error is not required. P value is required, important.
So this is p-value for this t value, right?
P value for this t-test statistic, yeah.
Okay.
Anything else? Okay, now this p-value is coming from the t-table, yes. Yes. Okay, now couple of things, right? So one, do you understand how do you build a linear regression model using statsmodel.api? The data format is you need to separate out y and x into 2 data frames and pass them, right? One thing that you should notice is, in this particular method, all variables present in this strain underscore x will be treated as x, right? You cannot have a variable which is present in here and which should not be treated as a x variable. Suppose within here you have a id variable, right? That will also be treated as a x variable. Do you understand? There is no way to select variables here. Okay, that brings us to the next method, which is statsmodel.formula API. Now, in statsmodel.formula API, what we do is we basically split the data not into 4 parts, but rather into 2 parts, right? We do not remove the x and the y. We just separate the total data into 2 parts, training and testing. Right? Previously, we had separated into 4, right? Train x, train y, test x, test y. Here, we are only separating this into training and testing. Makes sense? Okay. Now, the reason we do this is because in Formula API, there is a provision to mention which is your y and which is your x, which was not there in statsmodel.api. Statsmodel.api treats the whole X data frame as X variables and the whole Y data frame as the Y variable. That's why you had to separate them out. Here, there is a provision to mention which variable is your X and which variable is your Y. Okay. Now, how do you do that? Okay. Now, how do you do that? You do that by creating a formula, right? That's why the name Formula API. Now, Formula API understands a formula similar to this. You need to write y is equal to name of your first X variable separated by a plus sign, then the second X variable separated by a plus sign, and so on. You need to create a formula like this, right? Now, how do I create a formula like this? What I do is, first I get the name of the columns in the training data. Now this has both the X as well as the Y variables. Okay. Now, so once I get the name of the columns, the next thing that I do is I basically separate out the value of Y from the list. Just give me a second.
So this part of code is taking time and importing the module from sklearn. So is it stats model or formula API or sklearn scikit?
Sorry, what?
So method 2 is getting modules from sklearn.model. So it is the scikit or stats model.formula API thing.
No, it's statsmodel.formula API, right? sklearn.model selection is used to split the data into training and testing. This is not building the model. Yeah. Okay. Now, give me a second. I deleted one cell. Let me. Okay. Just 1 second. Just a second. Yeah. So the first thing that I'm doing is I'm importing from sklearn the model selection module, right? I'm within that I am importing this train underscore test underscore split, right? What this does is this will help me split this data into two parts. Now remember, I am not splitting X and Y here. Both training and testing will have X as well as Y. So if you look at training here, hyphens with a blank, right? Because a variable name in Python cannot have a hyphen in it. So this you see a bit of cleaning which I am doing.
Sir, can you repeat this? I mean, the connection got
There were
dropped.
some variables which had hyphens, right? So for example, if you go to the top here, let me see. For example, okay, so let me create this again. So if I write train dot columns, there will be one variable. I don't remember the name, which has a hyphen in it. Where do you see it? Mercedes B. Yeah, okay. So this has a hyphen here, right? Now hyphen cannot be present in a Python column name, right? So what I do is I replace the hyphen by a blank. So what happens to Mercedes B? It will just be Mercedes without anything B, right? So you see the hyphen has just been replaced.
Okay.
Now, once I do that, then what I do is then I join all the names of my X variable plus sign, right? So if I run this, what happens? All my X variables are written separated by plus signs. Now what I just need to do is I need to concatenate a Y with this. What I now do is I just concatenate my Y and I have the equation. So you see Y is equal to x1 plus x2 plus x3 plus dot dot dot. This gives me the formula which I will feed into the formula API, right? This formula helps Python identify that, okay, this is my Y and all of this are my X variables. Okay. Now let's start building the model. Now what I do is I import from statsmodel.formula.api, I import the OLS function. Same as we did in statsmodel.api. The only difference is instead of passing two data frames, I will pass my formula and the training data. Because within the formula, I have separated out what is my X and what is my Y, right? Now, as soon as I run this, I will get the exact same output. So you see the output is exactly the same, but there are two methods to do it. Now, why do I need two methods and where are they useful? Now, suppose you have a large number of variables and you do not want to create the formula or the formula will become too huge, right? In that case, you use formula.api. And if you have smaller number of variables, or if you have a scenario where the data frame contains variables other than x and y. So it might be that in your data frame you have things like address of a person, the customer ID, and so on. Variables which are not important in predicting the value of y, right? In that case, you will use Formula API, because Formula API enables you to select which is my x variable, which is my y variable. In statsmodel.api, so if you look at the difference, right? So let me copy this and paste it just below the statsmodel.api code so you can understand the difference. So if you look at this is statsmodel.api code, right? What am I passing here? I'm passing train y, train x. All variables that are there in train x will be treated as x variables. There is no way for you to choose. But in this particular case, since I have the formula, right, I have the flexibility to pick and choose variables that I need to include within the formula, right? And only those variables will be treated as my x. Makes sense? Otherwise, the output is exactly the same. If you look at the beta values, the p values, all of them will exactly be the same. The only difference is in the way they read the data. That is the only difference.
So in first,
Statsmodel.api needs to have two data frames, one with x, one with y. Statsmodel.formula API needs one data frame and one formula.
so in statsmodel.api, we got 95.5, I mean 0.95 as our value, R square, but in the second output we got 0.76. So why we
So
are
let me
getting
run
this?
this. Let me run this, right? So let me run this. You have got a R square of 78.4%. Something changed here, right? This is, I reopened the code and I think something has changed. I mean, something changed. So statsmodel.api gives you 78.4%. And if you look at formula API, you should get the exact same output. 78.4. The output will exactly be the same because the underlying engine is still stats model, right? What is different is the way they read the data. Make sense? Okay. Now, once you have built the model, the next step is to basically understand how much error is present in the model, right? Or how much error are you making while building the model. To look at the error metric, what we are going to do is we are going to primarily concentrate upon three matrices. One is MSE, which we all know. Second is RMSE, which is square root of MSE. And third is MAE, or mean absolute error, which is the average of the absolute value of the error. Make sense? Okay. Now, how do you calculate all of these? To calculate all of these, you need to import from sklearn a submodule called metrics. Right? You need to import a submodule called metrics. Within that submodule, you have the formula to calculate MAE. You have the formula to calculate MAC. If you take a square root of MAC, you have RMSE. Okay. Now for each of these matrices, the only thing that you need to pass are your value of y and your predicted value of y. Okay. Now, say for example, what is the name of my model? My model name is LM, right? This is the name of my model, right? Okay. Now, how do I get the predicted value of y using this model? I need to get the predicted value in order to measure error, right? How do I get that? Predicted value is obtained by writing model name dot predict, right? If you write model name dot predict, now to predict, what do I need? The x values. So I write train underscore x, right? Because I need to calculate first the error in my training data. So this becomes my what? This becomes my y underscore train underscore pred. This is my predicted y for training data. Make sense? Now, then what I do is I also need to calculate my error for the testing data. So I also predict my y for the testing data. Now, how do I do that? I do that by writing lm dot predict within bracket test underscore x. Make sense? Okay. Let me just run this once. Now, does it say? Okay, just 1 second. To run this. It tells me shapes 48, 41. Why is it giving me error? So the problem is with the test data. So let's look at the test data. Oh, okay. Okay. Yeah. So I have got the predicted for training. I've got the predicted for testing. Now let's choose one error metric, right? Let's choose MSE. Okay. Because looking at one makes it easier to interpret. So let's choose one error metric. Let's say MSE. What I'm now saying is I will calculate first the MSE for testing, right? So testing Y predicted is this. Okay. Now what I will also do is I will calculate the MSE for training. So my train X will be, so this is train and this is Y underscore training underscore predicted. Now if I run this, Let me import first. Yeah. Okay. Now, so how much error do you see in testing? It is 0.81. How much error do you see in training? 0.31. Now, what does this tell us? So what do you mean by this? What does this indicate when the training error is significantly lower than the testing error?
Test data is not, test data doesn't represent as well as the train data.
No.
Something, no?
No.
Has the high variance and
Overfitting, right?
overfitting.
This indicates overfitting.
Okay.
So training error is low, right? Which means the model has learned a good amount of information, right? Testing error is really high, which means the model is not able to generalize. So when the training error is low, testing error is high, it means there is a problem of overfitting, right? So this is training error, this is testing error. Training error is low, testing error is high. This means overfitting, because the model is not able to generalize. So if you think about it, right? So what we talked about overfitting, right? When did we say a model is overfitting? When it performs well on the training data, does not perform well on the testing, right? This, if you look at the testing case, the performance is significantly reduced, right? You agree, right? So that's why we will say there is a problem of overfitting. Make sense? Now, how do you reduce the problem of overfitting? By dropping some variables. You need to remove or drop some variables so that the R square actually reduces. Okay? Make sense? Okay. So we have looked at basically two methods to build linear regression. Any question?
So which variables we will drop when we see that R square, I mean to bring our model low from overfitting?
Sorry, what? I did not understand your question.
Yeah. So you said our model is overfitting, and to improve this, we will drop some variables.
Mm-hmm.
So which variables should we drop?
Yeah. So when you drop a variable, you should start with the variable which has the lowest value, lowest absolute value of beta. Start with that, because if you drop that, it will have the minimal effect on the prediction.
Okay.
You understand what we are trying to do.
Yes.
You have built a model which is too good. Now you need to reduce the performance. So what you do is you start dropping one variable which has the lowest absolute value of beta. The reason being that variable is least important for your model. So if you drop it, your R square will be affected the least, right? So you are losing power, but you are losing power small steps at a time.
Okay.
So you start with the lowest beta value. Yes. Sorry sir, आप क्या बोल रहे थे? हाँ, iterative process तो है. ऐसा तो नहीं है, मतलब one directional तो नहीं है. See, the reason this is iterative is the reason that you, me, everybody will have a job, right? If it is a one directional process, people would have written a code and it would have already been automated. Right? It's not a one directional process. It's an iterative process. Yes, a lot of the things can be automated. Say, for example, I just told you that you can automate the dropping of the variable part, right? Similarly, you can also automate the overfitting part as well. I mean, what you just need to do is look at the metric, right? If you see that the test error is significantly higher than the training error, you then dropping one variable at a time, starting with the smallest beta value. Right? That can also be automated, but 100% of it cannot be automated. Yeah. Yeah, you will have to first ensure all p-values are less than 5%, right? Now, out of that, which beta is the lowest? Okay. Now, any question?
Sir, when we check a multi-core
One
linearity
second,
and all,
one second, one second. Yeah. Mm-hmm. Mm-hmm. Sorry. Mm-hmm. Mm-hmm. Yeah. So what I am doing here is I want to compare the performance of my model, right? So how do I compare? I need to predict for the predicted value of y. That then only I can get the error, right? So first what I do is I predict the value of y for the training data. Then what I do is I predict the value of y for the testing data. Then I calculate the error. Right? So if you compare the actual value of y in the testing data with the predicted value of y in the testing data, what do you get? Testing error. Similarly, you do the same thing for training, you get the training error. Then I compare the training error with the testing error.
sir, for the good model, they should be closer to each
These two
other.
will be closer. Yeah, these two will be closer. Yeah. Makes sense? We will. We will. इसलिए नहीं check कर रहे मतलब आप you can do it either way. You can do that also before. But the logic that I will give is you first make sure that you have a model which is A significant, B good. अगर मॉडल अच्छा ही नहीं है तो आप तो यूज ही नहीं करोगे तो उसका एजम्पशन चेक करके क्या कर लोगे सपोज आपने एजम्पशन चेक कर लिया सपोज आपका मॉडल अच्छा ही नहीं है सारे एजम्पशंस वो सेटिस्फाई करती हैं विल यू यूज द मॉडल विल नॉट यूज द मॉडल सो फर्स्ट मेक श्योर दैट योर मॉडल इज गुड then check whether they satisfy the assumption. We will check. But first I want to ensure that I have an accurate model. Then I will check whether the model satisfied all the assumptions. This is what I would do. You can do the other way around. Now, let's look at how, so we have tested so far 3 assumptions of linear regression, right? We have looked at normality, although we have not looked at QQ plot. We will do that. Then we have checked whether X and Y are linearly dependent on each other. Then we have also looked at the autocorrelation bit, right? Now what we are going to do is we are going to now look at the VIF, right, which basically tests for multicollinearity. Now, to look at the VIF, what I need to do is I need to import from stats model outliers underscore influence. Within that, variance inflation factor, right? So I need to import variance inflation factor from this module. Okay. Now what I first do is, the first thing that I do is, in order to calculate VIF, I need to transform my data into a matrix format, right? What is a matrix format? Matrix format is a format where one of first column in the matrix is your Y, second column onwards you have your X values. Okay, that's what the D matrices does. D matrices will convert your data into a matrix format, right? Now, once you have converted into a matrix format, then what you can do is, then you can use variance inflation factor function to calculate the VIF. So if you look at this particular case, what I'm basically doing is, the variance inflation factor gives me the VIF. I'm calculating the VIF for all the X variables and then storing it in a data frame. So at the end of this, what I get is, a list of VIF values put in a data frame.
So y comma x you put it there. What is mean by
Sorry?
this? Y comma x DM matrix.
Yes. So DM matrix puts it in a matrix format. And then what I do is I separate out the Y and the X, because your VIF only needs to work on the X, right? You don't need the Y.
Okay.
Right? VIF is the relationship between X and X, right? So you need to remove the Y. Now, if you look at the VIF numbers, what I am looking for here is values greater than 10, right? Now, there is one value which is greater than 10, which is for the intercept. You need to ignore this, right? Intercept cannot be dropped. An intercept, in fact, is not a variable, right? So it is fine, right? Except intercept, do you see any value greater than 10? Which means there is no multicollinearity. Make sense?
Sir, after model building, before checking p-value, can we do VIF? Then we can check p-value. It is good, or we have to first check p-value, drop the variable, then come to VIF.
There is no order to it, right?
Okay.
Each person does their own thing, right? What I do is I first make the model significant, then check the VIF, but
Okay.
you can do the other way around as well.
Okay.
Okay, so there is no multicollinearity. So we have now checked 4 assumptions. Yes. Yeah. So for VIF, you need to first convert the data into matrix, then separate the Y out of it, because VIF should only be calculated on X, right? So this step does that. Once you have done that, then what this step does is, this step is basically iterating over each X value and calculating the VIF, right? And putting it in a data frame. Now, once you have done that, then what I am going to do is I'm just going to look at the numbers, right? And identify variables which have a VIF greater than 10. If the intercept has a VIF greater than 10, it is fine, right? If anything except the intercept has a variable as a VIF greater than 10, you need to drop it. Okay. Intercept is the constant, beta 0. Beta 0 is not exactly a variable, right? So you cannot drop it. Okay, now, so there is no multicollinearity present in our data. Makes sense? Next. The next thing that we are going to do is, we are going to test on the rest of the assumptions. But before that, any question? Yes. You are passing x followed by y formula. Yes. Sorry, y followed by x formula.
Sir, can we also check multi-collinearity between using the correlation also, sir? Just checking correlation between two x variable.
No, you have to write this formula. Yeah. You cannot check the correlation only because correlation gives you relationship between two x variables. Now there might be a multivariate relationship present,
Okay.
which is detected by VIF.
Okay.
So to detect multicollinearity, you should always calculate VIF. Model will be less accurate, yeah. Yes. Any questions? Okay. Now I will stop here. Now what I want you guys to do is, if you have time today, please go over this code and let me know if you have any questions. Or if you have this code, I have sent this last week, right? So you have this code. Go over this code and let me know if you have any questions on it. Okay? Let's say you check for overfitting, yes? Uh-huh.